take a look at these 3 images from National Geographic. One is an AI-generated image. Can you tell which one it is? Keep that in mind. We will come back to this later. We may have recently heard of AI image generators like DALL-E or Midjourney. All we have to do is type in a few words, and only a few seconds, several images are generated. Every day we may come across fake news and fake photos. Now this is not new. However, before, creating convincing fake images took some effort and image manipulation skills. But now, with AI, creating fake images has only become easier and requires almost no effort. But we need not worry too much. According to Professor of Computer Science and Engineering at the University of Buffalo, Siwei Liu, the good news is that humans have a natural instinct for sniffing AI images out. So, how can we sniff out these AI-generated images? Let's begin with understanding how these images are actually generated. According to Western Governors University, artificial intelligence, or AI, is the theory and development of computer programs that are able to solve problems and do tasks that are usually require human intelligence. All AI, whether ChatGPT, Alexa, or Siri, works by processing lots of data and by finding patterns in the data. Let's talk specifically about AI text-to-image generators. What this is saying is, the AI generator takes in our input, or the prompt that we type in, and then it tries to produce an image based on that prompt. There are different machine learning models that are commonly used in AI generation systems. One of these is called the Generative Adversarial Network, or GAN. A GAN works with 2 basic parts: the generator and the discriminator. The generator looks at real images from the dataset and tries to generate fake images based on the real ones. The discriminator's job is to tell the difference between the fake ones the generator created and the real images from the dataset. And over time, as we continue training the GAN system, the generator will get better at generating images that the discriminator cannot tell the difference between real and fake. Another popular AI image generation model is known as diffusion. Now, diffusion works with 4 basic parts: the image encoder, text encoder, diffusion model, and image decoder. In the image encoder, we take the training images from the dataset and translate those from pixels into vectors, or arrays of numbers that the computer can process. Similarly, the text encoder takes our input text and a semantic map, or the meaning and context of the words that it is trained on from a bunch of text data, and this is converted into vectors as well. All of these vectors go into a latent space, or a mathematical space where the computer can run the diffusion model. In the diffusion model, we have forward diffusion and reverse diffusion. In forward diffusion, we add noise to the image. In reverse diffusion, we are trying to take noise away from the image and add stuff based on the text input to generate a new image. Then, this information goes into the image decoder, which translates the new image from vectors back into pixels that we can see on our screen. Now that we know how these images are generated, let's examine some problems with AI image generation that may help us identify whether something is AI generated. First, AI does not know the rules or how things work. For instance, it does not know that hands have 5 fingers, as we will see in the coming images. Also, there may be a lack of data in some areas. Going back to the example of hands, the AI image generator system may be trained on lots of images of hands. However, maybe many of those images look like this or this, and not so many images of those hands look like this. So when we want to generate images with hands that look something like this, that will be hard for the AI generator to recreate because it has not seen any or many of those images. In Professor Siwei Liu's words, these programs only know what they've been given, and they don't know what details to pay attention to. And this results in artifacts, or problems with the image that are obvious upon closer inspection. This is an image generated in Midjourney by engineer and developer Mayo Zimmerman for a set of party images. If we take a look at these hands, there is something very wrong with them. This hand clearly does not have 5 fingers, and the other one is missing some joints and a pinky. Also, AI struggles with anatomy, so we see that in the bicep in the bottom right corner, it looks wrong. So let's go back to the 3 images of cheetahs from National Geographic. Again, one is an AI generated image. If you said this one was the fake, good job. Taking a closer look at this image, we can find those artifacts or problems that AI has with generating images. Most noticeably, we see a problem with the reflection in its left eye. Also, if we look even closer, we might notice that the pupils in the right and left eye don't actually match. AI image generation models, whether using a GAN or a diffusion model, are currently still limited by the image and text data they are trained on, and cannot understand how physics and things like hands work. These limitations create problems that can help us determine whether an image is AI generated. AI might improve, and AI-generated images could become more and more difficult for us to identify. But here's a good tip. We should always check our sources, including images, for credibility. Henry Fedrid, a professor at the University of Berkeley focusing on media forensics, agrees that we should be generally suspicious of media, to question its sourcing, and double-check its veracity. Thanks for listening.